Good morning. My name is Jonathan Lewis, and this is my final project. Today we're going to be doing a mock lesson on teaching probability in gaming concerning dice and its connection to Bernoulli's theorem. Um, so today what we're going to begin with is the basic idea that, of course, on a fair die, you're going to have an even chance of getting every number, equal chance of every result, let's call that. Now, this goes out the window when you toss in multiple dice, because at that point, your results form these bell curves. Now, it's an equal chance to get each combination, but the results are going to trend towards the middle. And that's Bernoulli's theorem, that over the time with tests, the more tests you have, the more your results are going to trend towards that theoretical average. Now, of course, we can also get that theoretical average by just adding many variables into the same single test. This is not, of course, a scientific operation that you should work with, but it does work for our purposes with gaming. Now, the reason for that is that as you get these more dice, the combinations tend to kind of cancel each other out because you have an equal chance of getting maximum and minimum, or two things that are of equal distance around the middle. So, of course, when you have those six-sided dice that our book usually uses, your average for each die is going to be 3.5. So for every two dice, your average is going to be 7. So that's how we get this bell curve. And the more dice you add into that, the larger, taller, but more stretched out this is going to become, lending you towards a trend of having almost 0% chance of getting these very extreme corners that are going to require your dice to all land on the same number. Of course, we can also calculate out the odds for those. So let's take a couple of examples of that. These are real-life examples I've experienced in gaming. So, for example, to stick with those D6s that we were talking about before, I've had times when I've had to use 60 six-sided dice. So we can calculate out pretty easily the probability of getting any particular combination. We're going to go ahead and look at it max, because who doesn't want to get maximum, right? So what we're looking at that is for that any one result that we want, it's going to be 1 out of the number of results to the power of how many tests, or dice in this case, that are being involved, how many chances that there are in that. So at this point, we've got 1 over 6 to the 60th power. I've already calculated that out because it gets to a pretty outrageous number. That's 1 out of 49 quintillion, or 489 and then 44 zeros. It's truly an outrageously large number. On the other hand of that, we have also a personal experience of mine, the D20s. Getting a 1 on those, that's a 20-sided die real quick, by the way. Getting a 1 on those is typically a bad thing. So I've gotten 5 1s in a row. That's a pretty horrendous time, and I went ahead and calculated out the chance of that as well. You can see I've done down here, so it's 1 over 20 to the 5th power, which comes out to 1 out of 3.2 million. Now, like I said, the more dice that you add into this, the closer you trend towards those middle numbers, and those outer edges are going to get rarer and rarer, but they do still happen. As you know, that's statistics. There's never a 0% chance of these things not happening, but that you get that greater and greater percentage chance that it's going to be closer to those medium lines, that top of the bell curve. And that's why it's at the top, because it has the greatest chance, because there are more combinations that can equal around in there than there are that can equal out towards the edges. So anyways, I'm running out of time now, but it's been a pleasure. Again, this is Jonathan Lewis, and that was Probability in Gaming and Bernoulli's Theorem. Goodbye.